But now we're going to hear from Aidan McGeary, who's the Managing Director of Green Power Systems, and he's going to talk about the move towards electrification. The construction industry, as you know, is looking to cut emissions drastically. Aidan can provide key insight into how electrification will impact the future of construction machinery. Welcome, please, Aidan McGeary.
Good morning, Declan. Thank you very much. So, good morning, and thank you for joining us at this conference with Plant Planet magazine. My name is Aidan McGeary, and today I'd like to introduce you to our business, Green Power Systems, and talk about the battery storage products we represent and share with you how this technology can be used as part of an electrification strategy by business and the wider construction and plant hire industries to achieve the net zero targets that have been set by government around carbon emissions. The need to decarbonise is well publicised, and I'm sure everyone listening is aware of it to some degree. And while there are many different approaches and ways carbon emissions can be reduced, electrification is a key one that can work for our industry. And while we have many years of development ahead of us, we can start today, as I will go on to explain. Green Power Systems are the exclusive distribution partners throughout the UK and Ireland for the Electric's power range of battery electrical storage manufactured in Austria. No electrification strategy can succeed without battery storage. The key is designing a strategy that suits the specific needs of each business, and this is where we aim to help both individual businesses and the wider sector. The construction side of the future is a concept that we have been working on for some time, and while there are many considerations to what contributes to the carbon footprint of a construction site, how a site will operate effectively with reduced emissions is one we believe is no longer a question for the future, but is a real and immediate requirement. Two solutions we can use our technology to deliver today are those of diesel generator hybridizing and construction equipment charging. Effectively hybridizing a diesel generator means several things, from being able to downsize the generator and still get the same results as far as power outputs, while also achieving reductions around runtime, fuel consumption, noise, and exhaust emissions, makes this a very attractive solution for an increasing number of sites. While hybridizing diesel generators is not a new concept, and it is something many operators will be familiar with, capability around our unit to support high voltage and high amp inputs and outputs, combined with the inbuilt distribution board, means many more applications can now be considered when deciding when a diesel generator can be hybridized. By stabilizing the load curve, we reduce the consumption of fuel per kilowatt of power produced. The peak power boost feature means that we can add the power from our battery storage onto the maximum power output of a generator to meet higher consumer requirements without increasing the size of the generator and the associated financial and environmental costs. As OEMs increase the size and number of their product ranges that are powered by purely electrical means, and end users' desire to use this new equipment grows, we expect difficulties to arise around how the infrastructure to provide the power to an increasing population of units will be developed. It is unlikely that the grid alone will be able to provide the necessary power, and certainly not at peak times. Therefore, we recognize that battery storage of this type, with its plug-and-play flexibility and scalability, will play a key role in facilitating a transition from diesel-powered equipment over to electrically powered equipment. In this example, Electric's teamed up with Volvo in France, where for 1 week, a ProBox unit was used to provide the power for an excavator and dumper on an off-grid island mode basis. As no mains grid power was available, this was done using an 80 kilowatt inverter with 140 kilowatt of batteries, and the onboard transformers, another feature of this unit, allows us to form our own grid. This solution is mostly suitable for applications where the equipment is being used on an intermittent basis or with lower power requirements over short to medium term timescales. But the unit's ability to deliver smart charging function means that we can ensure only the cheapest and greenest energy is used to power the equipment. In this other example in Europe, where the customer is not allowed to run diesel generators at certain times when working in certain towns and cities, By utilizing the ProBox, they are able to extend their working shifts and achieve efficiencies and cost benefits they wouldn't otherwise be able to. As legislation like this comes into effect throughout more cities around the UK and Europe, it is easy to see the benefits this battery technology can provide. There are several reasons why these products are so well suited to the industry, especially while it is working through this period of transition. While getting to grips with this new technology and trying to understand what configurations work best for it, the modular functionality allowing us to scale the size of the batteries as required is a welcome feature. The ability to easily add renewable energy sources to charge the unit are a key feature in ensuring it meets the requirements for a site or business wishing to implement renewable energy. The units have several unique features. On the power electronics side, we use bidirectional full hybrid frequency inverters. On the storage side, we use LFP, lithium iron phosphate chemistry. This means greater safety, stability, recyclability, lower thermal runaway, and increased efficiencies for the cycles and longevity of the battery modules. In addition to this, we have an active battery management system, which has been developed in-house, and going further is the network analysis module, which measures them and monitors the data coming from either the generator or the grid in combination with the battery management system. This can decide what power output is required. From the inverter to the battery management system and the NAM unit, everything is designed, flashed, and chipped in-house at X Electrics in Austria. In addition to the main features already shared, safety and environmental sustainability are paramount in the design of these units. Safety has been considered at the design and manufacturing stages of the cell, module, and unit level of the ProBox. And using LFP chemistry, which has many benefits over other more volatile and difficult to recycle alternatives. The wide range of unit sizes ensures we have the right size for any application and the ability to grow with sites as their own capabilities around electrification develop. Our partners at X Electrics have developed some very sophisticated software tools to help us understand individual applications and analyze the specific requirements, so we can then propose the most suitable solutions. From understanding the size of the generator, we can either produce our own load curve or take one from the client and analyze the data to be able to feed back what reductions we can offer in terms of generator sizing, runtime, fuel consumption, and CO2 output, complete with information on the ROI calculation. Before I finish, please take 2 minutes to watch our video animation, which we hope can explain one of the ways in which our technology can benefit business and the construction plant hire industries. We hope that you found our presentation of interest, and we look forward to engaging with anyone who wishes to understand more about how we can assist them with our plans to electrify their business on the path to achieving a decarbonised future. I'm happy to take any questions, or please contact us on the details shown on the slide. Thank you.
Aidan, thank you very much. Nothing like a bit of dramatic music to grab everyone's attention at the end of that. I don't know if that's what the young people refer to as a banging tune or not. Some practical questions coming in, and thank you for all your questions. You can use the Q&A function to ask your questions for Aidan. Daniel Bloom asks, are the generators particularly costly to run?
Well, these aren't generators. This is battery storage. So the concept is that we would combine this with a generator, and you know, the whole idea of hybridizing a generator is to bring down the running costs. So reduce the size of the generator, reduce the runtime of it, and ultimately the fuel consumption, and satisfy all the other legislative requirements that maybe don't exist today, but in the drive towards decarbonising, that is one of the objectives of the industry. So
sure. And John McKenna asks, how can he get hold of them?
John knows my number. He can give me a call.
A couple of questions for Julia Moore. Let's do them one after the other. Implementing this technology, does it require access to green energies, or can it be run off the grid?
It can be run off the grid. So the Pro Box will work in both on-grid and off-grid functionality. It's depends on the application, and this is where where the grid exists but maybe has limitations. As the requirement for charging more and more electrical machinery exists, and the grid is possibly not large enough to cope with that in certain sites and certain locations, that's a perfect application where this type of technology can step in to support the grid, reducing maybe more expensive infrastructure that might have to be brought in, and facilitating the ability for construction operators to implement more electric equipment. So working on grid and off grid is a function. The other benefit of this equipment is that it can work in an off-grid situation, but you can create a microgrid, a small grid on a site if the conditions allowed it, where it could be combined with a renewable energy source, it could be combined with generators, but it acts as it acts as its own mini grid, which is really one of the key. It's a key function that we think remote construction sites will need.
And is this where the idea that this is greener, that this helps the industry reduce carbon emissions, is that what underpins this suggestion that it is able to make use of electricity that's been generated from renewable sources? It's able to make use of its own renewable sources and capture that and then use it throughout the industry.
Yeah, so one of the typical challenges with renewables is that it's time dependent. So when the wind's blowing, electricity is there. When the sun's shining, solar panels are generating electricity. But when they go, so a construction site that has to run over a consistent period of time can't handle that lack of consistency. And this is where battery technology comes into play. So designed in, if we take into account the necessary outputs and requirements of the site, and we calculate what power we can generate from renewable sources, we can specify the battery appropriately.
The second question from Julia was, how scalable is the technology? What are the limitations on its use?
Look, in terms of scalability, we can go up to 250 kilowatt size inverter, 500 megawatt hour of battery, and it is a modular system. So we can plug extra battery storage in behind the same size inverter. I guess it has to work commercially, which is really the challenge in terms of how big it can go. I think it's really as big as any project will allow it to satisfy the commercial and the legislative requirements of a site.
Some questions from Maria. Will this require a change in current site configuration, or can it be slotted into place?
I think there's a bigger piece of work to be done around. I think it will be difficult to get any real benefit on most sites today. So there's a real planning process needs to go in. There's a real thought process, and I talk about the electrification strategy. I think any construction company that wants to explore this as a means to achieve a reduction in carbon outputs, it needs some thought. And this is where we would encourage people to engage with us and start to think about what they want to achieve, how they want to get there, and the batteries are part of that. They're not the whole solution, but they're a significant part of the solution. And that's the conversation we want to start talking about. The equipment is well publicized. Lots of OEMs are manufacturing the dumpers and the excavators. We just see a bit of a, maybe the infrastructure that's required for sites to be able to power that, it maybe needs a bit of work. And we feel that batteries is a key component of that.
And just as a follow-up to that, Maria also asked, does it require any special protections or create any hazards? No,
the units have their own built-in distribution boards, transformers. So from a safety point of view, as long as it's treated with the respect that electricity should be treated with, then it's there's nothing particularly hazardous about it. It's electrical power as we know it, just in a much more flexible form, which is probably important for this period of transition while people try and get to grips with how they can electrify sites more easily.
A question from John. You mentioned legislation around quiet working hours. Are there any other forms of legislation on the horizon which will help force the adoption of electric plant?
I'm probably personally not completely in tune with up to date with legislation as it currently is, but I think the feeling is there's a strong trend from government level and globally that this is a direction to travel. We talk to quite a lot of OEMs, we talk to quite a lot of tier 1 construction companies, and it's at this high level, this is very much the way it's going, and I would envisage regulations that we are familiar with in London around emissions and running clean engines. We would expect to see that sort of become more widespread.
Chris suggests that perhaps it should be made mandatory across the whole industry to have a battery like this on site. I can't imagine you disagreeing with that.
No, it's a period of transition. The point is, the end result is it's a lot like the previous presentation on autonomy. We'll probably never get to a place where every site complies with all of the concepts, but there is a journey here, and the end. We think we play a part in that journey.
Aidan, thank you very much. Thank you for your presentation and for sharing your insight with us. That's Aidan McGeary. He's the Managing Director of Green Power Systems.